Hello, class. This lesson is on precedence and associativity of logical operators. We're talking about the and, the or, and the not. Okay? If you look at this table here, table 4, it shows you the order of precedence. The not has the higher precedence, then your and then your or. Okay, so that's the precedence. So it tells us that the not and or has the same on the same level, but the not operator has a higher precedence than any of the C++ operators. Right? To avoid an error, you should always enclose an operand in parentheses unless you intend to apply it to a variable or a simple expression simple expression with no other operator. Now, look at the following examples. Here we have not and then collectively x greater than 2. So give an example. If x was 3, 3 greater than 2 is true, all right? Because 3 would be greater than 2, but therefore the not would make it false. Okay, so you got to remember that. The not reverses the condition, all right? So it's almost like saying x not greater than 2, all right? If you look at the second example here, where it says not x greater than 2, now we're going into our logical value. Remember our logical operator, our value. When you say not x, you're asking if x is what? 0 or any other value other than 0. So if x is 1, then that would be true, which would this would turn it to tell it that is false. If x was 0, then the not would turn it to be 1, to be say 1 is greater than it's still false. All right. So either way go here, x, not x greater than 2, the not says that it's going to either be 1 or 0. So let's look at it in a program, and then we'll continue on. So let's go to online GDB. So here we are in online GDB, and what I would do here, okay, I can kind of like comment this off, and I'll say 1, okay, less than 2, right? So this is commented. So this is not part. So looking at this expression, 1 less than 2, that would be true. You would get what? Yields true. So if we run this program, okay, it should yield true, right? But if we do it this way, remember everything always has to be in the in parentheses. So if we have 1 and 2 in parentheses. So now here we go. Okay, not a collective 1 less than 2. That's somewhat like our first example. So 1 less than 2, that's true, but it's going to yield false. So this is going to give us, it yields false. So let's run this. See, it yields false. So what it did, it reversed the outcome of this true condition. But let's look at this. Okay, we can take this off. I'll just take them both off, and we'll do it this way. Not 1. Now, when we say not 1, all right, what we are doing is 1 is equal to 1, but now we taking it and turning 1 into what? 0. So 0 less than 2, that will be true. So when we run this, it should give us true. You understand? So now I can make this let's say, make it 1,000. Okay, so 1 is equal to 1,000. Is 1,000 less than 2? No, but you got to remember this not is actually equating this expression here, not 1, to the logical value, either what, 1 or 0. So 1 is what? In it is not 0, so it's 1. So you wouldn't. So not 1 would be 0. 0 less than 2. That is true. So when we run this, we'll get true. See what I'm saying? So you just gotta watch. Now, sometimes you may not ever program using this in this fashion, but you got to remember this not along with the variable actually takes it and try to return that logical value, somewhat that Boolean value that we talked about in that previous section. Okay, all right. So you got to be wise of that. That not, if it's collectively used, when I do this, all right, it's taking whatever this expression is, 1 less than 2, that's true. So they're going to say false. Okay. And then the other way, it takes the actual value, the logical value. All right. So 1, wait. Oh no, okay, we changed the value to 1,000. So this 1 less than, 1,000 less than 2, that's false, but then this not turns it to true. I forgot I had changed this from 1 to 1,000. Okay, so you got to be very, very careful when using the not. All right, so let's get back to the notes. So it tells us the first expression which we use, which is this one, was collectively looking at x greater than 2 and taking that result and actually reversing it to either true or false, applies to the not operator to the expression. It applies the not operator to the expression x greater than 2. So it says, it's just simply asking, is x not greater than 2? So looking at this saying, is x not greater than 2? Because x without the not, we're saying if x is greater than 2. But with the not, is x not greater than 2? Okay? So the second expression, however, applies the not operator to x only. Now, when you have only x, all of a sudden now you are dealing with that Boolean value, okay, not x. Remember when we had the if statements where we had if sales quota met, remember? And if we use that integer Boolean value, it was like 1 or 0. Same thing here when you use the not on a particular variable. It's asking, okay, not x. Okay, so if x is 1 or to infinity or -1 to negative infinity, it will result to be 1. But the not says change it to 0. So looking at this expression, no matter what the x value is, it's going to be comparing, once you see this not here, it's either going to be comparing 0 greater than 2 or 1 greater than 2, which would always yield to be what? False. Okay, so that's all it's saying. So it's saying, suppose x was set to 5. Since 5 is non-zero, it would be considered true, so that the not operator would reverse it to false. Okay, so remember we talked about that. It would be 1 or 0. So, which is 0. All right. The greater than operator would then determine if 0 is greater than 2. All right, and then can say once that happens, 0 is not greater than 2, so they would yield to be false. Okay. To avoid a catastrophic a catastrophe like this, always use parentheses. All right. So, like I said, if you want just this, you could put parentheses around this. But you got to remember, and if you want all of this, you put the parentheses around all of this. But remember, if you're using it in like if logic, everything in the if logic, like I did, has to be enclosed in the parentheses. All right. So now it tells us the and, okay, and or operators rank lower in precedence than the relational operators. All right. So it says that here. So precedence problems are less likely to occur. So what that means is you always going to have to do greater than, or determine whether something is greater than, less than, not equal to, greater than, equal to, less than, equal to, before you perform your and your or. So that's simply what it's saying. All right. So if we look at this, A greater than B and X less than Y, you would have to do A greater than B, solve it, X less than Y, solve it, and then whether this is true and what or false, whether this is true or false, and you place it in your AND table. All right. Looking at this one, X equals Y or B greater than A. You have to solve for this to see whether it's true or false. Solve for this, whether it's true or false, and then use your OR table, logical table, so that you can determine whether or not the results would be true or false. All right. So it's saying that, and then again with the parentheses, you can write this out in this fashion. All right. Or you could write it in this fashion. But I would tell you, you can have 3 or more comparisons. Now, once that happens, sometimes you have to group them depending on how you're doing things, right? But let's look at this. You got parentheses here, then and parentheses here, then the other expression. Now, but if you put it in the if, you'd have to put parentheses to enclose everything. Give you an example. Let's get back to online GDB. All right. So looking at online GDB, if we go back and we take this off, all right, and we'll take our not off so we can somewhat not be so much confused. So we look at this. We say if 1 is less than 2 and 4 is greater than 3. But what we can do to try to say if we somewhat confused, we can always put our parentheses around our expressions here. But if you notice, well, I missed them. If you notice, I would still need to have my outer open and close parentheses to enclose everything within that if. Because what I'll do this. I'll take them off. Okay. I'll take them off like this, and then I'll run it. All right. So I got this enclosed and this enclosed. But I'm telling you, I will get an error because this if statement will try to look at only this as being part of the if logic, but when it sees this, you're going to get an error. So let's run it. So see, you got an error because now you have to enclose all of this information, all right, that you're comparing in that if logic so that it can run. So I put the parenthesis, open parentheses and close parentheses around the entire expression to evaluate. And now when I run it, I should get my results. Okay, so you see what happens, okay? Now, let's see, is 1 less than 2? Oh, I see. Well, what happened is 1 is 1,000. So 1 is 1,000 less than 2? No. So automatically that was false. So and with false and true, it will yield false. Okay, so that is correct. But if I go back and make 1 ONE to equal a 1, then now that will make that expression yield to be true. All right. So now it's true. All right. But you got to include everything in these parentheses. And as I told you, class, missing parentheses or parentheses in the wrong place, curly braces in the wrong place can cause you a lot of havoc. Okay. Can considerably change your logic in your program. Okay. So let's get back into the notes. All right. Now it's talking about checking numeric ranges with logical operator. So now this is somewhat like if you had a, say for instance, something dealing with, say, a particular average or score, like say a basketball player, and you're trying to determine whether or not that person would be able to qualify to be a part of a certain tournament or whatnot. So what you can say is, okay, we have the A group where if your average is between from 0 to 3.5, or when I'm just using the number, say from 0 to 25, the percentage point, from 0 to 25, then you're in the A group. Then you can ask if the average is between greater than equal to 25 and less than 50, you're in that group. So see how you can take a range, and then what you'd have to do, write your expression, and now you can actually write the code based upon a range. So what happens is, let's look at our notes. It says, logical operators are effective for determining whether a number is in or out of a range. Okay? And like I say, when you start writing code, you're going to realize that that's going to be a big part of coding. You have to determine whether something is within a range or not. Okay? So when determining whether a number is inside a numeric range, it is best to use the AND operator. So it's giving you a tip here, class. If you want to know if it's within a particular range, use the AND operator. Okay? For example, look at this example. If the statement checks the value in X to determine whether it is in the range of 20 and 40, then you would do something like this. If, and then X, which is our variable, if X is greater than or equal to 20, so you're starting at 20 and including 20, and less than or equal to 40. So you're including 40 and everything less than 40. So starting at 20, going up to equaling to 40. So everything in between that range would be acceptable. So let's look at our, go back to online GDB and look at that. So if we say something about, if we do something like here, if I said, I'll just do something like this. Int, I'll say range is equal to, let's say, give it a value, say 33. I could have done cin. And I'll do it that way. I'll say int range, cout, enter. Enter value for range, all right? And then what? Cin range, all right? So now we're going, every time I run it, I'll be entering a range. So now we said back with our notes, we want the range to be within equaling to 20 or greater and less than or equaling to 40. So if range is greater than or equal to 20, so that's including everything from 20 and above, but then we want to stop and range. Remember, we have to use a comparison on both sides, so range needs to be on the other side also. All right, and range is less than or equal to 40. All right. So that means if I put 20, it would be in true. All right. So what did they use? They used something like, okay, it was let's say I'll use the word that they use. Acceptable. That's the word they use. All right. Acceptable range. So let's go back to the online GDB. Okay. So we'll put in here is acceptable. All right. And if not, we'll put range not, and I'll just put the not capitalized. All right. So if we run this program, if we put anything from 20, anything above 20 and above and less than or equal to 40, it will be acceptable. Anything outside the range, 10, not acceptable. 50, not acceptable. 41, not acceptable. All right. So let's run this program. We run it. All right. And so it should ask us for the range if I wrote it correctly. All right. So in a range. So if I enter 33, 33 is greater than or equal to 20? Yes. Is 33 less than or equal to 40? Yes. So true and true yields true, which means that it will actually print range is acceptable. So it's going to do what the true condition is. So when I hit enter, all right, range is acceptable. All right. So if I run this again, all right, and I put a number less than 20, say I'll put 10, all right, is 10 greater than or equal to 20? Nope. Is 10 less than or equal to 40? Yes. So, but false and true yields false. You got to remember your table. So when I run this, all right, well, I hit enter, now it says what? Range not acceptable. Okay. Now, the same difference if I put in, if I run it again and I put something greater than 41. Greater than 40. All right. I can put 41, I can put 100, I can put 1,000, but anything greater than 40. So I'll put in 45. So is 45 greater than or equal to 20? Yes, that's true. Okay. And is 45 less than or equal to 40? Nope, that's false. So you got true and false, put in the table, in your AND table. True and false yields false. So this value is not acceptable. So when I hit enter, see, range not acceptable. So it will do the false condition. All right. So so that's all it's basically saying. So when you got to do it, if you're doing something, a particular range within, and you want to check within that range, use the AND. All right. Now, it tells us, and we're just explaining what we just talked about, the expression in the if statement will be true only when X is both greater than or equal to 20 and less than or equal to 40. X must be within the range of 20 through 40 for this expression to be true. Okay, what we just basically talked about. When determining whether a number is outside a range, the OR operator is best to use. So it's just giving you some key points, class. So when you have programs to write assignments, off top, you should say, okay, well, I've studied this, and they said, okay, this is the best practice for this. That's the best practice for that. So you shouldn't be somewhat confused when you say, okay, I'm trying to find something within a range. Oh, and I'm trying to find something outside of a range. Oh, or, it should just click. All right. So let's look at this example. So it tells us when you're trying to determine something outside of a range, the OR operator is the best to use. All right. So let's look at this one. It says if X is less than 20 or X greater than 40. Now you're looking at this. If I typed in 20, is 20 less than 20? No, 20 is equal to 20. All right. So you got to understand in this example, the value 20 and the value 40 is not acceptable values for this particular expression. Okay. 20 does not will give you false, and 40 will give you false. All right. So let's look at this. So let's go to our expression that we have in online GDB. All right. So here we have our range here. We're going to enter the range, but now we're going to change this, and we're going to say less than. But we're going to change our what? Logical operator to R. All right. Remember, that's the pipe symbol, which is hold on the shift key and the backslash. Okay. And greater. So now, whatever I put in for range, if it's less than 20, it'll be wrong. If it's greater than 40, it'll be wrong. Because remember, with R, either side can be false, and no, either side can be true, and it's true. All right. So what happens is, so here, when I put in a number, if I put in 33, is 33 greater than 20? I mean, less than 20, is range less than 20? No, that would be false, all right? But is it greater than 40? No, all right? Is range less than 20? No. Or range greater than 40? No, I got that backwards. Let's see, no. Oh, this is less than. Is range less than, greater than? Let's go back to the notes. Right, that's right. All right. So, is range less than, oh, that's right. This would be, if this range is less than 20, 33 less than 20, that would be false, all right? If 33 greater than 40, that would be false. Let me run this. Right. And if it was less than or greater than, and now I'd have to change this. Let me go back. I won't run it. I'll stop it. All right. So what happens is now I have to change this because what? If it's less than 20 and it's greater than 40, right? Then I'm gonna say what? It's not acceptable. All right. Because I'm trying to find the values that are outside the range. So I'm going to cut this and paste this here. All right. But like I said, you could have written it the other way, but we're following what the book example is. Then we'll cut this. And paste this. All right. So if it's less than this, or if it's greater than this, all right, it's not acceptable. All right. But otherwise, it is acceptable. So let's run it. So now we run it. Okay. So if I put in 20, all right, 20 is not included in that. It should say is acceptable. No, it's not acceptable. I did it backwards. True. Okay. Wait a minute. Let me see something. Range. Oh, okay. Yeah, 20. Okay, that's right. It is acceptable. I'm confused. All right. So what? Because 20 is not less than or equal to. It's just less than. So when I run it again, all right, and if I put in 10, all right, it's not acceptable. All right. So 10 is not acceptable. All right. So run it again. Put 45, 43, or whatever. and hit enter. All right, not acceptable. But notice I have to reverse this, right? So let's look at this note. So if x is less than 20, all right, and well, that's the and, all right. If x is less than 20 or x greater than 40, see how is outside the acceptable range. All right. So that means, okay, if this is true, I'm going to do this. So remember in my online GDB, what happened, I'm checking it in the reverse, so I had to make this the negative part. All right. So the negative really was the true. And then this was the false, all right, which was the acceptable. All right. So that's how that works. All right. Now, let's get back to the nodes. So it tells us it's important not to get the logic of these logical operator confused, all right? Operators confused. For example, the following if statement would never test true, all right? Now, what it's saying is if x is less than 20 and x is greater than 40, you will never get this output here. Because what? It can't never be both of them. Remember with and, both sides has to be true. So a number like 10 is less than 20, but the number 10 can never be greater than 40. So that and part, you'll never perform that and condition. So you have to be mindful. Okay? So it's saying obviously x cannot be less than 20 and at the same time greater than 40. Okay, so note that C++ does not allow you to check numeric ranges with expressions such as 5 less than x less than 20. Remember, we got to use the variable operator, another variable or constant, and then and or the variable and operator, and then another variable or constant, okay? Such as this. Remember, we had P and Q, the operator, and then whatever, when I say P and Q, you had two different operators or variables, checking to see if it's greater than, less than, equal to, not equal to, etc. You solve that, but then you got your logical operator, and then now you have either a repeating of the same variable or any other two variables or variable and constant on the other side. Okay, so you cannot. I know in math you can do this: 5 less than x less than 20. You know, you can do that with that, but you can't do that in C++. All right. So remember that you cannot do that. So hopefully you understand this part of the lecture, and so this concludes this section.